Hello, my name is Maya Morozak, and I will be discussing our model on parking spot availability and identification in parking lots for Group 19. Our motivation for the project stems from frustration we have had when trying to park on campus, and we feel that parking spot identification could help students save time when finding parking, which would increase student attendance and decrease parking lot violations that occur from students not being able to find the empty spots. This can be expanded to situations outside of our campus, such as a mall on a busy day. And our goal for this project is to design a neural network solution to identify empty spots from a parking lot image with the number of empty spots and area the spot is in provided to help direct people to the spot. We use two data sources from Kaggle with our model. The first data set provides images of individual parking spots with around 3,000 images of empty spots and 3,000 images of non-empty spots, and examples are shown on the bottom of the slide. And then the second data set provides complete parking lot images with around 30 images. However, we chose to test our model using only four full parking lot images. For our baseline, we trained a CNN model to classify the state of a parking lot image that is focused on only a single space, and our model would identify whether the parking spot shown is empty or not empty for the image. For our current model, we built upon the baseline and used a lightweight CNN with two convolutional layers that extract spatial features to identify the spot as top left, bottom right, etc. And this employs ReLU activations and fully connected layers to classify the images into the two labels of empty and not empty. Here is a look at our code. And our current model takes the inputs from the second parking lot dataset that provides the collection of multiple spots, and we manually drew bounding boxes onto these images to identify where the spots were, and then used a model to crop the images to a single spot and place them into folders based on each image. And then the output is the classification label of the parking spot state, which is either empty or not empty. For our training and validation, we split our data into two sets. 70% of the original data was the training data, and then the other 30% was used as validation data to check how the model was performing. And we were able to do multiple rounds of training and validation. Our current model also uses a CV2 from Python library to identify the annotated spots that were drawn within the bounding boxes, and then use that data to crop out single image spots. And based on the spot placement, it would separate the spots into quadrant folders to give a general idea of where they are. So on the right, you see the image has the green bounding boxes, which were the ones we provided with the image, and then the pink are what is being identified by the model. And here it shows how the cropped images are saved, so the spots are separated into the four quadrants of the parking lot. Here we have an overview of how the four lots we used performed. So this is the image of what the lot looked like, and then the numbers where it is identifying empty versus non-empty spots, but not always the correct number. Lot 2 was more overhead, but a slight angle. And then lot 3 had some wet spots on the ground, which we wanted to look at because the parking lot will not always be even colored. This one also picked up empty, and actually 3 quadrants were able to be identified correctly with only the top left missing 2 empty spots. Then parking lot 4 was similar, with some correct and a few being labeled incorrectly. We feel that there were major issues with the images, which were not directly overhead, and the model would sometimes detect things other than cars in the spots, such as small parts of other cars, and it would identify the spot as not empty even if a car could park there. For our model analysis, we looked at accuracy, which is the number of correct predictions, precision, which is the number of spots that were correct out of the spots labeled empty. Recall looks at how many empty spots were correctly identified overall, and then the F1 score is a balance of precision and recall. Overall, here are our metrics for the 4 parking lots. We had an 84% accuracy, a 65% precision, 49% recall, and a 45% F1 score. And this is lower than the metrics we were getting for our baseline model, where it was identifying based on solely the clean empty versus non-empty spots of our data set. Overall, we were able to successfully develop a model that detects parking spots, determines whether they're full or empty, and then gives a cardinal direction for the available parking spots. We saw a decrease in our evaluation metrics with our overall model, but we feel this could be caused by optimization issues in our baseline model, such as overfitting. In the future, we would like to update our model to be more generalized, have better metrics, and have a better overall performance. And we feel that with some tweaking, this model could be used in bigger situations and applications, such as using security camera footage as the inputs to the model for an unknown parking spot. Thank you.